Hey everyone, my name is Ari and I'm a quantum hardware engineer at IBM. And in this video, I'm going to tell you literally exactly step by step how you can become a quantum engineer. And basically, what I'm going to have you do is just like turn your brain off, follow the steps, and then you'll more than likely become a quantum engineer if you actually do the work and follow the steps in this video. So, the first thing that you need to know is don't do any of this Qiskit stuff. Don't do any of this Nielsen and Chuang quantum information, Griffith's quantum mechanics. Don't do any of that yet, at least. These things are ultimately distractions in you becoming a successful quantum engineer. We'll come back to this stuff, but ignore all of this for now. Everything I'm going to tell you here today is based off of my own experience and the experience of other people that I know who have built careers in quantum computing. And when I was going through school, going through college, trying to build a career in quantum computing, it was incredibly difficult because there was no resources online to help quantum engineers, the people who actually want to be engineering the systems and the quantum systems, to build a career in quantum engineering. I basically want you to turn off your brain and just listen to what I'm saying step by step. And as long as you do everything that I'm going to say, you're probably going to be able to get a job as a quantum engineer. Now, that said, even if you don't want to end up doing quantum engineering at the end, or you're not able to get a job, or something happens and you're not feeling well and you don't follow the system perfectly, that's fine, because everything that we're going to be doing here today is ultimately going to be very good for your career. And no matter what happens, you're still going to probably be able to get a six-figure or above job when you graduate. So let's get started. Quantum engineer is basically somebody who engineers the systems that go into making a quantum computer actually work, right? So if we want to build a quantum computer that is practically useful for the world and can actually run quantum algorithms that are useful, we need to make a quantum computer both scalable and fault tolerant. Basically, what that means is we need to increase the size of the quantum computer, increase the number of qubits in the quantum computer. But we also need to make those qubits such that we need to make the qubits more resilient to errors, and two, we need to develop a system that can actually correct for those errors. So what quantum engineers do is they really kind of touch on the scaling aspect of that primarily. Like, how do we build a fridge that can cool down all of the infrastructure that we need to build a quantum computer, right? How do we set up a measurement apparatus in this fridge to measure the latest quantum computing processor? How do we develop control electronics so that we can send data to and read data back from the qubits? And that's what I work on. I work on scaling qubit control electronics so we can actually build a practically useful quantum computer for this world. Okay, so ultimately we need to know what makes a good quantum engineer. A good quantum engineer basically boils down to two things: your technical skills and the behaviors. And the behaviors broadly mean like your soft skills, your mindset, and your personality. That's actually a really large part about getting a job and working on a team is your soft skills, which means that kind of like your communication skills, the mindset that you have, how you work with people, how well people get along with you, and how much they like you, right? That's going to help you, one, not only have a better career, but two, just be a better contributor to your organization. So technical skills are probably the most important thing, but don't sleep on the fact that your behaviors, your soft skills, your mindset, your personality, how you get along with people is going to be really important. This is just the reality of how the world works. Okay. You can't just expect to be the best person technically and then get a job if people hate you, if you suck. If people don't like being around you, they're not going to want to hire you. Okay. So I'll talk more about that later. But what is the first step? Okay. What do you need to do? This is the process that you can follow step by step. And if you follow step by step, you'll probably get a job in quantum engineering eventually. Okay. So the first part is you need to study electrical engineering. Just listen to me, study electrical engineering or computer engineering if you really want to lean more towards the software side, but like electrical engineering if you want to do more hardware stuff, computer engineering if you want to do more software stuff. So essentially, electrical engineering and computer engineering, they provide the foundational knowledge for quantum computing. Literally, it tells you pretty much everything. And I'll substantiate that claim by talking about a story from this guy. So this is Eli Levinson Falk. He's a professor of physics and electrical and computer engineering at USC. And he runs a superconducting qubit research lab. Okay. So he gave this talk a little while ago. It's called Teaching Design, which means like, okay, how do we take people who are just starting their PhD and teach them how to design superconducting qubits, right? And so this first slide is like how we should probably do it is bring in the electrical engineers, right? Is basically like teach them everything that's the core to an electrical engineering curriculum. Okay. Because basically, all of the core skills that you need to know for quantum computing and specifically quantum engineering, and even like the PhD level stuff, like designing superconducting qubits, is all based off of electrical and computer engineering principles. So these are just kind of the basics of some of the things that you'll learn kind of core in electrical engineering. It really focuses on circuits, signals, systems, and kind of your basic electromagnetics physics. So these are kind of the things that you really want to pay attention to when you're studying electrical engineering: is electromagnetics, signal processing and systems, embedded systems, linear systems, circuits, and Python. Okay, I use Python like every day. Everyone I know at work at IBM uses Python. So you need to know how to code in Python. And then electromagnetics basically provides you with a solid foundational knowledge in physics, right? And electromagnetics are basically exactly how we control and read data to from qubits. No matter what paradigm, hardware paradigm you're using, you use some sort of electromagnetic wave, right? Then you need to understand how you can process that electromagnetic wave. As far as the electives, what you want to take, in addition to kind of like the core electromagnetics or core electrical engineering, you want to take modern physics, because that's going to give you some sort of basic introduction to quantum physics. Essentially, all you want is some basic introduction to quantum physics, and you should be able to get that somewhere in your electrical engineering curriculum. Then you want to take RF and microwave engineering, which is basically electromagnetics, but focusing on like how we communicate with with electromagnetic waves in the RF and microwave regime, like in the gigahertz region, right? And so this might not be directly applicable to, like, it might not be a course that's like applicable to quantum computing, but it might be like satellites, or it might be like integrated RFIC design. You just got to find like your university what that actually means. And then from there, like some of the most important things are lab classes that teach measurements. You need to know how to use lab equipment like an oscilloscope, a vector network analyzer or VNA, time domain reflectometer or TDR, DC sources, all that kind of lab equipment. You want hands-on experience, because that's going to be stuff you can put on your resume. That's actually going to make you useful when you're in the lab doing research, measuring something, testing something, putting something together. You need to know how to use these things. If you have the chance to take device physics, a lot of device physics principles are important not only for superconducting quantum chips, but also semiconducting quantum chips. And also they're very important for control electronics. Everything's moving more towards application specific integrated circuits. And so if you understand device physics, you'll be able to kind of understand how, circuitry works in general. So in general, then, if you have the chance to take electives, the university allows you to, and they offer quantum computing courses. Like, take the quantum computing course, take the quantum engineering course. Like, I went to the University of Wisconsin, right, which is like it's just a normal state school. It's nothing special. It's literally in Wisconsin. People tell me sometimes they don't even know where Wisconsin is, right? And so, um, I went to the University of Wisconsin, but thankfully they have faculty there that do research in quantum. So there were some classes in quantum computing, there were some classes in quantum engineering. So I took those classes, right? And that helped me. Okay. So the next thing that you're going to want to do after you started studying electrical engineering is you want to immediately join the quantum computing club. And if you haven't yet joined the quantum computing club, or if there isn't yet a quantum computing club at your university, you are going to start it. This is like the first thing that one of the first things that you're going to do once you kind of get your bearings is you want to join if it's already available. And then maybe when you're like a sophomore or something like that, or maybe a junior, and you're starting to understand quantum computing a little bit more, then you should start it. Because here's what this gives you: a network of people that you can meet, and those people help you get an internship, might help you get a position in a research lab, might help you get your future job. Okay. But then they also like basically just give you access to community of people that can help motivate you and keep you accountable and support you and offer you opportunities and resources. That's kind of like the biggest thing that a club and a community offers. And so when I was at university, there wasn't a quantum computing club, but I started it. And honestly, probably one of the most fulfilling experiences that I've had. But in any case, active participation in the club, it develops your leadership and your communication skills. If you are the leader of the quantum computing club, you are going to become, one, an excellent leader. You need to practice leadership if you want to be a good leader. Two, you're going to develop really great communication skills, because you're going to have to get in front of people and talk to them and talk about quantum computing, or at least facilitate other people talking about quantum computing. Regardless, you're going to have to develop your communication skills, both written and oral. And these things, just starting the quantum computing club or becoming, the vice president or the president or something on the executive board of the quantum computing club, is literally going to be one of the most important things that you're going to do for your quantum computing career and your quantum engineering career. Okay, moving on. So once you've kind of gone through some of the electrical engineering stuff and you joined the quantum computing club, now you want to basically focus on experience. And what I mean by experience is anything that you can pretty much put on your resume or discuss in an interview. So you want to first start by trying to acquire some sort of technical experience beyond your coursework in ECE, electrical and computer engineering. So it's either an internship or research. You want to be doing internships and research literally as soon as you can get them. Don't be like one of those people like, oh, I'm going to take summer classes. Like, no, do an internship, do something real, right? Oh no, I'm going to enjoy my summer. No, you can still enjoy your summer and you're going to do an internship. You want to have career success, not enjoy your summer. So take the time to do a research, try to get research, summer research, go to a lab, do it for free, or get some sort of internship. And then simultaneously, you want to acquire quite literally any experience that you can in quantum. Quantum's kind of like a gatekeepy, it's kind of hard to get some quantum experience. And so, one, that's why I'm making some of these videos to help you. But two, just get anything that you can in quantum computing. And then, most important thing is you need to build some sort of foundational knowledge. So my whole message is you don't need to learn Qiskit. Where is it? You don't need to learn Qiskit and all this stuff. Like, this is such a distraction. You need to be developing your electrical engineering skills and the skills that are actually applicable to developing quantum computing. Like, yeah, okay, if you're really interested in quantum information theory and quantum algorithms, then study those things. But this is not, the channel is not for those people. The channel is for people who want to be quantum engineers. And so don't waste your time with Qiskit. Don't waste your time with Griffith's quantum mechanics. Don't waste your time with Nielsen and Chuang. Like, if you Google how to learn quantum computing, you just get force fed all this stuff. It's really frustrating, right? Because that's not the type of thing that is going to actually help you get a career in quantum computing. So don't do any of this yet, at least. Okay. You can start with foundational stuff. You don't need to know like all the theory and whatnot. You need to just know a little bit about it. You need to know some sort of basic understanding. Okay. So what is the basic understanding that you need to know? You need to understand a little bit about quantum physics. You need to understand what superposition is, entanglement, interference. You need to understand the quantum properties that make a quantum computer a quantum computer. And you need to understand how we actually leverage those quantum properties. So that then kind of goes into quantum information. How do we leverage the properties of quantum physics? How do we write about it? What's the notation? What's Brockett notation, right? Just get a basic understanding. Because if you're going through, what can happen is like you go through some of these, this Qiskit and quantum mechanics and Nielsen and Chuang, and then you just get kind of demotivated. At least I got demotivated because I didn't really like that stuff, right? It took me a while to realize that all I needed was a foundational knowledge in all of that stuff. I didn't need to be an expert in quantum information theory. I don't need to know quantum algorithms. I don't really need to know quantum mechanics that well, but just well enough so that I can do my job. Okay. And so you need to develop a basic understanding of quantum physics, quantum information, and then quantum hardware. How do we actually build a quantum computer? Is you're going to be a quantum engineer, you're going to be interfacing with the hardware in some way or the software that controls the hardware. Pretty much in some way, like that's what all quantum engineers do. And so you need to understand, how do we build a quantum computer? Superconducting, semiconducting, neutral atoms, trapped ions, maybe look a little bit into the Majorana qubits from Microsoft, right? Just kind of understand, like, how do we build a quantum computer? And then how do we control qubits? How do we send data to and read data back from them? Just get a little bit of a basic understanding. Watch YouTube videos, watch my videos, watch somebody else's videos, read textbooks. Okay, and I'm going to actually plug this textbook, not sponsored or anything, but this textbook is like the electrical engineer's Bible for quantum computing. It's like basically, I mean, it goes a little bit too in depth. I think you honestly don't need to know everything from here, but like it basically tells you exactly step by step. So I should really just make this a step. Read this textbook. This is like a step. You need to read this textbook. It needs to go through it. Like, depending on where you are in your coursework, you might not understand, but just go through it a little bit to try to understand it. And this will give you, honestly, if you read this textbook, you literally have every skill you need to be a quantum engineer. If you know Python and you've read this textbook, you can be a quantum engineer, hands down. It's that simple. Okay, so to get some experience, read that textbook, go to quantum hackathons, do personal projects, do the Qiskit Global Summer School. You can go back to old ones, you can do future ones. And then again, be a leader in the quantum computing club. Join the quantum computing club. That's part of your experience. So then what you're going to do is you're going to use that experience to then get some real experience, some tangible experience in quantum computing. So you're going to use your technical electrical engineering skills and your basic knowledge of quantum computing to get an internship, research in a quantum computing lab, or summer research at like a national lab. And these are going to be the experiences that are going to get you the job. And not only are they going to get you the job, but they'll also kind of inform what you actually want to do. So if you have a lot of time, maybe you have, 2 more semesters left, or 2 more years left, right? What you can do is you want to iterate on kind of what you are getting an opportunity in and what you like doing. Okay, so let me actually go back. So this is what's going to get you the job. This is also going to enlighten you to what you like to do in quantum computing. Okay. You don't just want to, and I know it's going to be really hard to get this first experience, but this first experience will allow you to get then another experience. So, what you do after you've gotten this first experience, whether it's an internship, research, or something at like a national lab or summer research, is you want to pick a specific niche in quantum computing and quantum engineering. Broadly, like my niche is quantum control systems, right? So, you want to pick a niche, whether that be quantum control systems, something like mechanical design, cryogenics, chip design, fabrication, and process engineering. So that means like getting those suits on and like going to the clean room and making stuff. You can do just test and measurement. Like, okay, we have this chip, measure it. We have these electronics, measure it and test it. System integration, which are like people who like literally build the quantum computers. Like the people who like, okay, we have to build this quantum computer. Who's going to put it together? It's like quite literally the people who are there building the quantum computers. You can be one of those people, right? So once you've picked a specific niche in quantum engineering, you then want to develop a specific technical skill in that niche. And again, your technical skills are the most important thing for getting a job in quantum computing and quantum engineering. And honestly, your technical skills and what you focus on here might be the reason why they hire you over somebody with a PhD in like quantum computing or theoretical quantum physics or something like that. Like, I'm not necessarily saying that like you with a bachelor's or a master's is always going to be better than those people. But if you like kind of focus on learning stuff that is directly applicable to what the industry needs, and you're going to get a job. That's basically what I did, right? I picked quantum control systems after basically, here's what I did is like I joined a research lab. So my first real experience in quantum computing was I joined a research lab in neutral atom quantum computing. And I literally had like no idea what I wanted to do. I just knew I wanted to do quantum computing. I had like actually zero idea. So then I started working in that lab, and in working with that lab, I started to understand, okay, what actually has to go into making a quantum computer. I learned a little bit more about the physics, learned more about the control and the infrastructure around the quantum computer. And then I started developing a niche, like, okay, this kind of like control systems, electrical engineering infrastructure, that sounds kind of cool. So then I started developing skills in that niche. And then I used my lab experience to then get another real experience in quantum computing at IBM. And this was directly in the quantum control systems lab at IBM. And so from there, I was like, okay, like quantum control systems, I love quantum control systems. Like, that's my niche. I'm going to pick that. So I dedicated myself to the quantum control systems niche. I continued developing that specific technical skill. Um, and then from there, it's like you just finish up school. Then from there, you're pretty much like almost ready then to get a job, right? So if you're doing an internship, for example, like just try really hard to get a return offer. And if you don't, that's fine. We'll talk about that later. Something that I think is like honestly almost just as important as technical skills, and this is just the reality of how the world works. Like, you might like it, you might not like it, but this is just the reality of how it works. Like, you need to have good communication skills, right? And communication is literally the most underrated skill for every scientist and engineer out there, period. And so the reason why is like when you get in an interview, like you basically just have to make people like you. And if they don't like you, they're not going to hire you. Just no matter how good you are at whatever technical thing, the people who are interviewing you just have to like you. And so if you're not a likable person and you don't get along with the people who are interviewing you, they're not going to hire you. So you can be super good at whatever you do technically. But if you're, not good socially, you can't communicate what you're doing, then you're not going to get the job, right? It amplifying your communication skills, it really amplifies your ability to be a good scientist and engineer. Because in addition to just like getting the job, you need to then communicate what you find to the world. You need to communicate what you find and you've discovered to your peers. And so the better that you can communicate that information, the more impact you are personally going to have on the world. Okay, so how do you develop these communication skills? Be part of the quantum computing club leadership. Start the club if it doesn't exist. Become the president, become the vice president. You're going to learn how to lead. You're going to learn how to teach. You're going to learn how to present. You're going to learn how to communicate technical topics. And those are like some of the most important things. From there, do what most engineers don't do, is try really hard in like the communication and writing classes. So at my school, there was this class, it was a technical communication class, and everyone totally blew it off. They're like, this class is so stupid. Like, I just want to focus on my engineering classes. No, don't be that person. Be the person that literally gets 100%. And that's what I did. I literally tried super hard in my communication class and got a 100%. And honestly, that class was one of the most useful beyond any of the technical classes, one of the most useful class I ever took. Um, from there, focus on trying to develop skills on communicating technical information to non-technical people. So just Google that, look it up, watch YouTube videos, go to like YouTube channels on communication skills. I'll put some links in the description too. And then also, this is something I wish I did more of too, but make more time for like social events and hanging out with people, because that just like makes you more charismatic, makes you more comfortable in social situations, makes you more comfortable talking about like the work that you do. Just go to stuff, have fun, and try to develop yourself as a person in addition to like somebody who's really good at technical things. So this book gets recommended a lot. It's called How to Win Friends and Influence People by Dale Carnegie. It was written in like the 1930s, I think. It's basically just like a common sense manual for how to talk to people and be a nice person and be liked. But honestly, like it wasn't common sense. I read it and it like wasn't, not everything was common sense. Like engineers and scientists, like the stereotype is true. Like we don't communicate very well. And some of the stuff is not common sense. And so if you feel like I mean, I felt like my communication was really bad. My communication was really bad in the past. Like I had a lot of trouble communicating what I was working on. I had a lot of trouble in social situations when I was younger. And I realized that that was something that was holding me back. So I developed myself in a natural way that was authentic to me, to become a better communicator and become somebody who can communicate what they're working on and what they're talking about better. And that has honestly amplified not only my success, but also amplified my impact on the world, because then I'm able to communicate what I'm working on. Okay. So after this whole long rant about communication skills, you basically take your communication skills that you developed, you take the real experience you've gotten in quantum computing and the specific technical skills that you've developed, and then you apply for jobs, or you get a return offer from your internship. And so if you're applying for jobs, you get an interview, they like you, you riz them up with your communication skills, you show them your technical skills, they give you the offer, boom, success, full-time quantum engineer. But, okay, if you can't get a job, or maybe you want to go deeper, maybe you finish your bachelor's degree and you want to go deeper, we can return to the start and just get a master's degree. And that's actually what I would recommend. And that's exactly what I did. Is I actually had the opportunity to come back full time to IBM in the quantum control systems lab as just finishing my bachelor's. But I wanted to go deeper, and I actually wanted to get a little closer to the real quantum computers. And so I decided to get a master's and go deeper. And so let's go all the way back to the beginning. And so now you study electrical engineering or computer engineering, but now you're getting a master's. So one thing I will say is don't do a quantum computing master's. Focus on building depth in a technical niche in quantum engineering. There's like tons of these quantum computing master's degrees. I think all of them pretty much cost money. And I don't know all of the curriculums, but in the curriculums that I have seen, they basically focus on teaching you, where is it? This stuff that I'm telling you exactly, don't do this because it's a distraction. They teach you this stuff. They teach you quantum mechanics. They teach you quantum information theory. They teach you quantum algorithms, but then they don't teach you any technical skill. So if you are somebody who's like doing one of these quantum computing masters, like start taking a bunch of electrical engineering courses and like try to get electrical engineering skills so you can like be somebody who actually has a tangible technical skill. So again, you're just going to go through the same thing. You're going to join the quantum computing club, or you're going to start the quantum computing club, you're going to lead the quantum computing club, you're going to get technical internships, you're going to do research. And now this time it's going to be kind of more focused because you've already known your niche, right? You already know kind of about quantum computing. You already have the foundational knowledge, so you can kind of start to build that. And honestly, even if you're somebody who's working in industry right now, so let's say like you have really strong technical ability, you're 5 years into working as a hardware engineer, but you want to work in quantum computing, okay, you can start here. Study electrical engineering and computer engineering, get your master's, then start building your experience and foundational knowledge in quantum computing. And go from there. Try to get an internship in quantum computing, try to work in a research lab, try to do summer research at a national lab, and just go through the cycle again. Keep iterating on this loop to discover what you like and then what you're good at, get real experiences, develop your communication skills, develop your technical skills, and then eventually you'll have success. If you follow this framework, you can just turn your brain off, follow this framework. It's going to be a lot of work, but this will be what helps you get a job in quantum computing as a quantum engineer. Do good work, everyone, and I'll see you in the next video. Bye.